All right, we are going to get our notes out of the way first today. Our warm-ups. Find the slope of a line through -9, -4, and -3, 8. We are not going to write the equation of it today. We'll worry about that another time. For now, we are just going to find the slope of that line. When we're given 2 points, how do we find slope? M equals? Somebody started saying it. No. Y2. Good. All right. So when we plug in to find the slope of this line through these points, what's my Y2? 8 minus a -4 over, what's my X2? -3 minus what? -9. Subtracting a negative means I'm really adding a positive, so I can change it to one big plus sign. 12 over 6, which is 2, or 2 over 1. Either one of those would be fine. On number 2, we are asked to solve the equation. That means we need to get x alone. Anybody have any thoughts on what needs to happen first?
Parentheses.
Sort of. What do you mean by that?
Multiply 3x. 3x.
Good. We got to multiply the 3 to the x and to the...
-15.
Good. We got to distribute the 3. When we distribute the 3, what do we get? 3x minus 45 still equals x plus 11. What would we do next?
-11. No.
We could do that.
Why don't you subtract it?
Okay, I like subtracting the x to get all the x's together. Whatever we do to one side, we have to do to the other. So 3x minus x is
2x.
2x, still minus 45, still equal to 11. Now we would
Add
45.
45.
add 45. We have 2x equals
No.
Divide by 2.
divide by 2.
X equals 28.
X equals 28. It's been a while since we've solved an equation that took that many steps. Questions about it? Dominic.
Will we be seeing this on our homework assignment as well?
Probably not exactly like that, but maybe a similar idea. All right, let's get back to our warm-ups. The last one asks us to use intercepts to graph. So let's first talk about finding our x and y intercepts. This seemed to be an issue on our test. To find the x-intercept, we're going to plug what in for what?
0.
0 in for
Y.
y.
And then
To find the y-intercept, we plug 0 in for
X.
x. Okay, so let's start with our x-intercept. We're going to plug 0 in to y. So -4x plus 2 times 0 equals 16.
Can't you really just put -4x equals 16?
Sure, because 2 times 0 is just 0. That goes away. How would we get x alone?
Divided by -4.
Divide by -4.
X equals -4.
X equals -4. Very good. To find the y-intercept, we're plugging 0 in for x. Yes, when we plug that in, that first term really just goes away.
Divided by 2.
What would y equal?
8.
Good. Okay, so we have our 2 points. All you have to do to graph it then is graph those 2 points. So when we graph those points, let me pull up a grid here. And I'm going to erase some of this stuff above. Y-intercept. Well, that'll be close enough. All right, I'm going to count by 2s on my grids. So 2 here, 2 there. If my x-intercept is at -4, 0, where is that in relationship to my origin? To the left, since I'm counting by 2s, this is -4. So -4, 0 is right there. In relation to the origin, where is my y-intercept 0, 8? Up. So I would go up 2, 4, 6, 8, and put a point there. I just need 2 points to make a line, so then I could graph the line through those 2 points. Now, if you didn't graph this warm-up, that's no big deal. I know there wasn't a graph there for you, but you should have still found your intercepts. Questions about any of the warm-ups? Okay. Anybody need more time on this page? All right. Then I'll give you a minute to get down your objective. Today we're doing section 4.2, writing equations in point slope form. So that is part of our objective, to write the equation of a line given its slope and a point or 2 points. We're still going to be writing equations, but we're going to look at a new form. All right, in our notes, we need to know what point slope form looks like. So point slope form for a linear equation is written y minus y1 equals m parentheses x minus x1. So it's called point slope form because it passes through the point x1, y1, and of course has a slope of m. So when we write it in point slope form, we are going to be replacing y1, m, and x1 with numbers. Like last week, we just replaced m and b with numbers. This week, we've got 3 things to replace with numbers. The rest of it's going to look the same. So if we are asked to write it in point slope form, we're going to have parentheses there. We're not going to distribute and get rid of them. Point slope form would just mean we replace the y1, the m, and the x1 with numbers. The y, plane y, and the plane x would stay the same. Need more time on this slide, okay? For example 1, kind of like last week, we're going to start off with the easiest type of examples, and they'll get a little more challenging as we go through them. So for these, they give us a point, -8, 3, and they give us a slope of 1/4. So the general form for point slope form is y minus y1 equals m parentheses x minus x1. So in this case, what is my y1? What y value do they give me?
-3.
-3 or -3?
3.
3. They give me a 3 for y. It's in the second position in the coordinate. Okay, what about my m? What'd they give me for m? 1/4. They gave me that as my slope. What about my x1? negative 8. So I'm going to rewrite this same equation that I wrote on the top of the slide. It's in that box of notes we just did on the last slide. And all I'm going to do is replace y1, m, and x1. So the plain y stays the same, minus what? 3 equals, what comes next? 1/4. Open my parentheses. Careful, x. Why is it plus 8? Good. Normally it would be minus and it's a negative 8 in there. So instead of writing minus a negative, we should just write plus. That's all we're doing. That is our answer. We are not distributing because if we were to distribute, then it doesn't look like point slope form anymore. Okay, go ahead and try letter B on your own real quick if you have not already done so, and we'll talk about it in just a moment. So what was the y1 that they gave us? 3, the m, and the x1. Okay? So when I start writing my equation in point slope form, it would be y minus 3 equals 1/2 parentheses x minus 2. Good. Why didn't we change any of these to plus signs?
Because the 2 is positive.
2 was positive and the 3 was positive, so they keep their same sign. Okay. That would be our answer. Questions about example 1? Yes. The minus 2 back here?
Yeah.
So the formula for it, the generic one, has a minus sign. So when I plug a 2 in there, it just stays a minus sign. Whereas before we had plugged in a negative number. That one had been negative, so it switched it to be adding. Good question. Other questions? Ready to move on? Okay. All right. If we are writing equations of lines given 2 points, we've got 2 steps. First step is to find the slope of the line. Anytime we write equations, no matter what form you're writing it in, you are going to want to know the slope. Then you will use the slope and 1 point to write the equation of the line in point slope form. So this step 2 means that you are going to have to pick a point to use. You have to pick from the ones they gave you, but you get to pick which one you use. So the tricky thing on some of the other examples that we're going to do is that there are technically going to be 2 correct answers. Anybody need more time on these notes? All right, well, let's give it a try. Write the equation in slope-intercept form of the line. Okay, so they're switching it up on us. The directions this time say slope-intercept form. What does that look like? Y equals mx plus b. So our final answer needs to look like that. But we are not given b, right? It's not even on the picture they gave us for this one. Neither of these have a coordinate of 0 for x. So we can't do it like we did last week. We have to start off doing it like we did example 1, where it was in point slope form, and then we'll change it. So let's start just getting to point slope form. If I want to get it into point slope form, well, I've got 2 points, that's fine, but I need to find my slope. So let's start by finding slope. How would I find the slope?
6 y1. I mean y2 minus y.
Okay, so negative 6 minus 6 over negative 2 minus 4. What is that going to give me?
No, 12. Negative 12.
Negative 12 over negative 6. A negative divided by a negative is a positive. 12 divided by 6 is 2. So a positive 2. Then we have to pick a point. It really doesn't matter. Either point would work. Do you want to use the first one or the second one? First one. Okay. So I like to circle the point that I'm using, and then I can kind of ignore the other one. So if we're doing it first in point slope form, that's the new one that was in our notes on the front page, then that's going to look like y minus what?
2.
Y minus
6, your y coordinate. So remember, this would be your y1 equals, what comes after the equal sign?
6. M.
M, so that would be 2 or 2 over 1. And then those parentheses open.
6
X minus 4. So this would be my x1 that I'm plugging into that formula. This is point slope form. If you want to make a little note to yourself, you could do that. This is point slope form. And that's fine. That helps us, but that's not what they wanted our final answer to be. They want our final answer to be y equals mx plus b in slope-intercept form. We're not too far off. Okay, we need y to be alone. So in order for y to be alone, what would I want to do technically? Add 6. But can I do that when I've got parentheses over here? Not really. So what do you think I need to do first? Somebody said it. Dominic, what do you think?
Distribute.
Good. We need to distribute what? What number? The 2. So first we'll distribute the 2. What will that give me? 2x minus 8. Very good. Now we're ready to do what? Add the 6. We talked about that's how y would be alone in the first place. We just weren't ready to do it yet. Now we are. So we would have y equals what? 2x minus 2. Is that slope-intercept form? Is that y equals mx plus b?
Yeah.
Yes, that's slope-intercept form. That's how they wanted our answer, so we can stop. So if you want to make a little note next to that, that's slope-intercept form. So that way you can see the same equation in both forms in the same problem. If point slope form is where you want to be, then we could stop at step 2. But if we need to go to slope intercept form, we had to do a couple more steps after that. So after it was in point slope form, right after we wrote point slope form, what was the next thing we did? On that last problem we just did, right after it was in point slope form, how did we start to get the y alone? Distribute. So step 3 would be to distribute slope, or distribute the m. Distribute the slope, or m. And then what was our step 4? What was the very last step before we had our final answer? We ended up adding, so we'll have to get y alone. Usually that means we'll have to add or subtract. And then at this point, your answer would be in slope-intercept form. So if all you need is point-slope form, you could stop at step 2. But if you need it in slope-intercept form, you'd have a couple more steps to take. All right, so when we read our directions, again, we already did this once. We're going to focus on letter B now. The directions are to put it in slope-intercept form. So when I say write down the generic equation for that, in this case, I'm talking about y equals mx plus b. That's what I want my answer to look like. Again, they didn't give us b, so it's not as easy as it was on Friday. Anytime we're trying to write the equation of a line, though, the first thing we should try to identify is what? Just slope. Okay, we just need to know what m is. It's a little bit easier when they give you a graph because you can count your what over what? Rise over run. So my rise is going down how many? Down 4, so that would be what kind of 4? A negative 4. Negative 4 over, what is my run? Positive 2. Negative 4 over positive 2 simplifies to be negative 2. Questions about finding our slope? Okay, technically you could find your slope just by using those points that they gave you on the graph and using your slope formula, y2 minus y1 over x2 minus x1. If you did it that way, that's fine. All right, now we've got our slope. Y-intercept is not visible to us, so we need to pick a point so that we can do point-slope form. Which point do you want to use, the top or the bottom? Okay? We are. All right, so we picked our point to use. I like to circle the point I'm using. So first we are going to put this in point-slope form, and then we will change it to be in slope-intercept form. Point-slope form starts off with y not equals minus what? 2 in this case, that's my y1 coordinate, equals what goes right after the equal sign? M, which is negative 2. Then we open up those parentheses, and in the parentheses we would have x minus 1. Good. So remember, we used our y1 and then our x1 from this point that we decided to use. Again, that's our point slope form. I'll just label it PS form this time. Point slope. But I don't want it in point slope form. I need to take it all the way to slope intercept form. So the next thing I'm going to do is distribute the negative 2. So we have y minus 2 equals what? Very good. We need to be careful with our signs. A negative times a positive x makes that a negative 2x. But a negative 2 times a negative 1 turns us to a plus 2 in the back. Make sure you're keeping track of your signs during this process. Otherwise, your answer will not end up right. And it's very easy to make a sign error. You've got to pay really close attention. One more step. We need y to be alone, so I'm going to add 2. Now, we didn't make a big deal about this on the last one. I kind of just took it for granted. But on this one, if I add 2 on the left side, where should I be adding 2 on the right side? To the plain old 2. Why? because it doesn't have an x. Make sure you are lining up your like terms when you do this. All right, so we're ready to write our answer. Y equals what? Negative 2x plus 4. That would be our slope-intercept form. I'll put SI for slope-intercept. Questions, concerns about example 2? Are we sure? This process is new and it's a little bit long. Okay, we're ready to move on then? All right, example 3 is going to look kind of familiar because we did problems similar to this last week with the function notation. So you might remember the very first thing we had to do was turn the function notation into the points that it gives us. So f of 8 equals -1. What point does that give me? What did they plug in for x? 8. And what did they get out as their output? Good. What about f of 6 equals 0? 6, 0. Now, looking at this, I see a 0. Is that my b? No, why not? Good. We would need these numbers to be flip-flopped. Your 0 would have to be for x if this was your b. So we don't have any shortcuts. We're going to treat this just like we did on example 2 for the rest of the problem. Now, the directions didn't specify, so we kind of default to we want it in slope-intercept form. But with the function, I'm going to put f of x instead of y. Let's go ahead and write our points for letter B, and that way you can work on these on your own for just a minute or two before we do them together. For letter B, what's the first point that they imply with their function notation? 4, -2, and the other one? 8, 4. Now on both of these problems, you're going to follow those 4 steps we put in the box at the bottom of the front of your notes. You're going to find your slope. You're going to pick a point to use to put it in point slope form. You're going to distribute the slope into the parentheses, and then you're going to get y alone. So if you would rather write these as y equals mx plus b, that's fine. We could always switch it over to an f of x for our final answer. So take a few minutes, do the steps that you know how to do. You could start with those. You should all know how to find slope. We've practiced putting it in point slope form together a couple times. You could try that. See how far you can get on your own. All right, let's talk through example 3A. And maybe I'll give you another minute to wrap up B. So you've got one more example to look at to try it on your own. On 3A, to find our slope, what are we doing in the numerator? y2 minus y1. What's going in there?
0 plus 1.
Good. 0 minus a -1, so it becomes 0 plus 1.
6 minus 8.
And then in the denominator, we would have 6 minus 8. 0 plus 1. 6 minus 8. Okay, so we've got our slope. Then we got to pick a point. Now, you can pick whichever point you want, technically. There is a little bit of strategery you could use here. What's always an easy number to plug in? 0. So I would always lean towards picking the point that has a 0 in it. If you didn't, it's fine. You should still get the same answer in the end. But I would always recommend picking a point that has a 0 if it's there. So when I plug into point slope form, I would have y minus what? 0 equals negative 1/2 parentheses x minus what? 6. I've got to use the 6 and not the 8 if I used the 0. I got to stick with that point. That's why I like to circle it when I do that. What is y minus 0? What's 8 minus 0? 8 minus 0? 8. What's 10 minus 0? 10. What's y minus 0? Y. So this makes it easy because now the y is already going to be alone. When I distribute the negative 1/2, we got to watch our signs. Yes, we would have negative 1/2 x plus 3. Good. A negative times a negative turns that positive. So we really only had to take one step to get from the point slope to slope intercept because y minus 0 is just y. All right, let's go ahead and go through B. If you didn't quite get it done, you'll be able to finish it up now. When we find our slope, what's going in my numerator? Okay, minus a negative 2 turns that to 4 plus 2. The denominator, 8 minus 4. You've got to have your slope formula down. You got to be able to just plug those numbers in and find it really quick. 4 plus 2 is 6. 8 minus 4 is 4. This reduces to be what? 3 over 2. Okay, we've got our slope. We need to pick a point. Which point do you want to use? First one? It does not matter to me. You've got to pick a point. If you used the second point, you should get the same answer in the end. Your work will just look a little bit different. We plug into point slope form. That would be y minus negative 2. So this is going to turn into what? A plus 2. Equals, what goes after the equal sign? The m, 3 over 2. Open your parentheses. X. What goes in there? Minus 4. Okay, this one's not quite as easy as 3a. We're going to have to take 2 steps. The first step is going to be to do what, Dominic?
Distribute 3/2 x and 3/2 minus 4.
Good. Distribute in that 3 over 2. Okay, so 3/2 x is just 3/2 x. That's not really changing. So we've got a positive times a negative. We know it'll come out to be a positive times a negative is a negative. You've got to take 3 over 2 times 4 over what number? 1. 2 ways you can do this. You can reduce and then multiply straight across the top, straight across the bottom, or you can multiply first and then reduce later. So either way, what's 3 times 4? 2 times 1? 12 divided by 2 is 6. So this would be a minus 6. Questions about how we got a minus 6 there? Okay, last step, get y all alone. We need to subtract 2 on both sides. I should line the minus 2 up underneath what? Underneath the 6. So minus 6 minus 2. So I'm left with y equals 3/2 x. Negative 6 minus 2 is negative 8. There's our answer. Again, if you want, you could switch these to f of x instead of a y, but I'm fine with a y on these. That's a pretty small detail in a problem that takes a lot of steps that you've got to remember. All right, questions about example 3? All right, let's move on. We've got an application problem. To ride in Best in Town taxi, you pay a start fee and a mileage fee. The table shows the total cost of a taxi ride for different distances. Can the situation be modeled by a linear equation? Explain. If possible, write a linear model that represents the cost as a function of the number of miles. So first, let's just decide, is this linear or not? That's something that we should know how to do from last chapter. So how are the distances changing in the table?
As of by 4 by the chart.
So it's not always by 4, right? They kind of switch it up. So first they're adding by what? 4, and then they add 2, and then they add by 2 again. So, okay, that doesn't necessarily mean it's not going to be linear this time, though. We still need to see how the cost is changing. So for the first one, they're adding what? 10. The next one, they're adding 5. The next one, they're adding 16. Okay. So, we would want to compare the cost to the distance, because remember, when we make a table, it's input or x over y, so we want to compare the change in the y's to the change in the x's, and we can just line them up. So if I do y over x, my first fraction would be what over what? The y change was 10, the x change was 4, what would that reduce to? 5 over 2. The next one, what's my y change? 5 over my x change? 2. So these ones are the same, but what happens when we go to the last one? What's my y change? 16 over... Is that going to be the same as those 5 over 2s? No. So because of that, a linear model will not work. A linear model does not work. Rate of change is not constant. Ooh, running out of space. Okay, it looked like we were going to get a constant rate of change from the first few numbers, but that last set of numbers threw us off. So if we cannot represent it with a linear model, then we're not going to write one. So you can just cross off the rest of those directions because a linear model will not work. We can't do it. Questions on this one? All right. Last one. It's going to be the same idea. We're deciding if a linear model works, and if it does, we're going to write the linear model that represents it. So we won't read through the whole thing to save on time. You can read through that. You could label these as your X and your Y again. How are my number of foam hands changing? They're going up by 2 every time, which is nice that that's the same each time. What about my cost? What's the first one going up by? The next one? Still 12. Next one. Next one. So is a linear model going to work? Yes, the rate of change is constant. And if I look at my rate of change, my y over my x, what is it going to be? What was my change in y? 12 over 2, which equals, guess what letter that represents? Rate of change is the same as what thing that we always find?
Rise over run.
Rise over run. What's our other name for that? Rise over run is our slope. So 6 is which letter for us? Slope is M. That was our rate of change. So that's going to help us write our linear model. Then we just have to pick a point. You were given 5 points. Which one do you want to use? We only need one. The first one? Sure. It doesn't matter to me. You use your first point. Remember, x is on top, y is on bottom. We'll put this in point slope form first. So y minus what? What was the y value that we circled? 34. Equals. What comes after the equals sign? The 6 for our slope. Open those parentheses. What's in there? X minus 4. We still need to get this in slope intercept form, so we are going to distribute y minus 34 equals 6x 24. Last step. Add 34. So we have y equals 6x. Not minus 10. Plus 10. The 34 was bigger.